Time in space is a little more complicated than what we experience here on Earth, and that's because of two key effects: gravitational time dilation and velocity time dilation. First, let's talk about gravitational time dilation. This means time moves differently depending on how strong the gravitational pull is. The closer you are to a massive object, like Earth, the slower time passes for you, compared to someone farther away. Astronauts on the International Space Station are orbiting about 400 kilometers above Earth, where gravity is weaker than at the surface, so time actually moves slightly faster for them than for us on Earth. Yeah, I'm technically aging a bit faster up here, but we're talking about 0.02 seconds every 6 months. Not exactly a fountain of youth. Next, we have velocity time dilation. According to Einstein's theory of relativity, the faster you move, the slower time passes for you compared to someone at rest. The faster you go, the more noticeable the effect becomes. NASA's Parker Solar Probe is the fastest spacecraft ever built, traveling at speeds up to 700,000 kilometers per hour. While that's a small fraction of the speed of light, it's still enough to experience a measurable time difference. At these speeds, the probe experiences time dilation, although only by milliseconds. Still, over years of travel, those milliseconds add up. If you were aboard the probe, you'd age just a tiny bit slower than people on Earth. These effects become much more pronounced at extreme speeds, like near the speed of light. But for everyday space travel like the ISS or the Parker Solar Probe, the difference is tiny. Still, it's a reminder that time in space isn't quite the same as time on Earth. Even though these time differences are small, they remind us that space isn't just about distance, it's about how time itself behaves differently up here. Time in space, a little faster, a little slower, but always in motion. To put it in perspective, if you spent a year on the ISS, you would age about 0.01 seconds less than someone on Earth. This might not seem like much, but it's a fascinating demonstration of how gravity affects time. Now let's consider the implications of velocity time dilation in more detail. Imagine a spacecraft traveling at 90% of the speed of light. For the crew aboard, time would slow down significantly compared to those on Earth. A journey that seems to take a few years for them could span decades on Earth. This is why understanding time dilation is crucial for planning long-term space missions. It's not just about the physical distance traveled, but also the time experienced by the crew. As we push the boundaries of space exploration, these concepts will become even more important. Whether it's a mission to Mars or beyond, understanding how time works in space will help us prepare for the challenges ahead. So, next time you look up at the night sky, remember that time up there is a bit different from time down here. It's a reminder of the incredible complexities and wonders of our universe. Time in space, a little faster, a little slower, but always in motion.